Everyone, Ismail is here. Today we're going to start the new lesson and new chapter, chapter 6. Now, as you can see here, we have some get ready for the chapter. So this is a linear system of equation. So do you remember how to solve system of equation of two function? I think we have multiple way to solve it. One of way is the elimination way. Elimination way, for example, let's write it here. 2x minus 3 equals 7. Then 3x plus 2y equal 14. Okay, so if you remember the elimination, which is we need to eliminate one of the variables. Sorry, this one is 14, not 114. Okay, so now as you can see here, I need to eliminate x. So to eliminate x here, I can just multiply the whole equation with 3, and I can multiply here the whole equation by 2. So 2 times 3 and 3 times 2. So now we just distribute the whole equation with the number. So it will be 6x minus 3y, okay, equal to 7 times 21. Okay, so this is the answer. Then here the same thing for the second equation. So let's say 6x plus 4y equal 28. So this is how we can multiply, because my goal is to eliminate the x, and now to eliminate x I need to make the constant here equal to constant here. So now I can minus, so 6 minus 6x, okay, so 6x minus 6x equals 0. Now, negative 3 minus 4, which is negative 7y, equal to 21 minus 28, which is equal 7. So now we can divide both sides by negative 7, divide by negative 7. So now the final answer y is equal negative 1. So after I found negative 1, I can replace it in the first equation to find x. 2x minus negative 1 equals 7. So the answer will be 2x plus 1 equal 7. 2x equal minus 1 for both sides. So this one cancels. So 7 minus 1 is equal 6. Divide by 2, divide by 2. So x is equal 3. Now the system of equation is x and y. And you know that x and y, if we go down, it will be 3 and negative 1. So this is how we solve the system of linear equation, what we learned in grade 8 and grade 9 and so on. Now in this lesson, which is 6.1 multivariable linear system and row operation, in this lesson we're going to learn new things about the system of equation. Solve system of linear equation using matrices and Gaussian elimination. So we're going to learn how we can solve the system using Gaussian elimination. Then solve system of linear matrix use Gauss-Jordan elimination. So here we have two things to learn. The first one is Gaussian elimination. The second one is Gauss-Jordan elimination. What's the difference between them? We are going to see. Now, first thing, before we start, here, let's start with Gaussian elimination. Gaussian elimination, let's read together. A multivariable linear system or a multivariate linear system is a system of a linear equation in two more variables. And in the previous example, we learned the elimination method. This is the elimination method that we did in the first example to solve the system equation. Now, one elimination method begins writing a system using an inverted triangle shape. Okay, inverted, which is leading coefficient are 1. Okay, so this is my Gaussian elimination. Gaussian elimination is to make, as you can see, this is the flipped or inverted triangle, which is, as you can see, the first constant x, the first variable x, the constant here is equal 1. In the second equation, y here also the constant is equal 1. Also z here also is equal 1. So as you can see here, the inverted triangle, all the constants for all variables must equal 1. So after all of these are equal 1, I can just identify z is equal negative 2. Now I have z negative 2, I can substitute it here. So it will become y plus 4 times negative 2 equal to 5. So I can just find y by 4 times 4 times negative 2, 8, negative 8, then plus 8 to the other side, so the answer is equal 13. So now I have y, I have z, then I substitute y here, then I substitute z here again to find the value of x. So this is the Gaussian elimination, which is I can find one of the equation, then by that one of the equation I can find the other. Then, now let's go to the second part. after we understand the Gaussian elimination. Here the book just explained the steps step by step how he did it. We are going to go through these steps, but first let me just do it at the beginning, or let me just tell you the tricks how we can solve them, or the way or the steps. First thing, write the system of linear equations in triangular form using Gaussian elimination. Always read the question before you start solving, because sometimes the question will ask you and you will feel that this way it's easier than the other, but you must follow what the question asks you. Now let's start here with the first equation. Now I have here three equations. First step number one, okay, write this step in your copybook or as notes. So step number one, okay, give name or give a name to each, okay, to each equation. Okay, so for example, this equation, this is equation 1, and this equation here is equation 2, and this one will become equation 3. So I have now three equations. Step number 2, solve using elimination. Solve equation 1 with equation 2. So this is step number 2. Solve equation 1 with equation number 2 using elimination. Now 5x minus 5y minus 5z equal 35. Equation 2, negative x plus 2y minus 3z equal 12. Okay, now, but if you look here to this two equation has three variables, and you ask me to use elimination, okay, to solve equation 1 with equation 2. Okay, so I will add in one things, solve equation 1 with equation 2 to eliminate, okay, to eliminate one of the variable, x, y, or z, anyone. So let's say to eliminate x. Step number 3, we are going to solve equation 1 again with equation, okay, 3 to what? Because we eliminated x here, so we must eliminate x again in the second one. If you eliminate y in the first step, okay, you can start here, eliminate y. If you decide to eliminate z here, you must eliminate z here. So it based on which variable you decide first to eliminate, so you must eliminate it again in the second, or in the second step. Then step number 4, which is the last one, okay, solve equation, okay, A with equation B. Maybe some of you, okay, to eliminate, okay, to eliminate, okay, y. Now maybe some of you will ask me, teacher, where's A and B? We are going to get A and B from solving equation 1 with equation 2. This is what we get A. Then equation 1 with equation 3. This is equation B. We are going to see now. Then solve equation A. Now, notes. There's important note. The important note that we have, okay, divide, okay, by a common factor. What's the meaning of common factor? Which is, if you can simplify the equation, you must divide this equation by the common factor. Don't just go multiply without finding the common factor. So now, for example, now as we are going to follow now, we give name for every equation. We give name for every equation. Step number 2, solve equation 1 with equation 2. So I wrote equation 1 and I wrote equation 2 next to each other. Now to eliminate x, so I need to eliminate x here and here. How can I eliminate x? Maybe some of you tell me, teacher, I can multiply the second equation times 5, okay, then I get 5x and negative 5x, then I can eliminate. Okay, that's completely fine, but don't forget, before you start multiply or use the elimination, don't forget this important note that I wrote to you here. Divide by a common factor before you start. Now look to the equation 1. Do we have a common factor between all the three terms? Yes. Here it's 5, here it's 5, here it's 5, here it's 35. So I can divide the whole equation. I can divide the whole equation by what? By 5. Okay? So divide the whole equation. Let me write here. So divide divide the whole equation by 5. So now if I divide the whole equation by 5, so 5x divide by 5 is equal, and then minus 5y divided by 5, then minus 5z divided by 5, then 35 divided by 5. So now 5 cancel, 5 remains x, minus 5 cancelled, y, this one also cancel. So 35 divided by 5 is equal 7. So now do you see what equation 1 become? So equation 1 become x minus y minus z equals 7, which is much easier than multiplying 5 for the second equation. Now let's rewrite the second equation. So the second equation is negative x plus 2y minus 3z equal negative 12. Now let's solve equation 1 with equation 2. So as you can see, let's add them together. X plus minus x, they cancel each other. Negative y plus 2y is equal y. Negative z plus negative 3z is equal negative 4z. Now 7 plus negative 12 is equal, you can just add them like normally. So the answer is equal negative 5. Okay, now after we solved this equation here is become my equation. After I eliminate x, this equation here I will call it a. So do you see now from where the a comes from? Yes, a comes from solving equation 1 with equation 2. So do you think equation b will come from where? It will come from step number 3. So from step number 2 I will get equation a. Now from step number 3, okay, solve equation 1 with equation 3. So equation 1 is x minus y minus z equals 7. Then equation 3 is equal, what's equation 3? Let's go up, okay? So equation 3 is 3x minus 2y plus 7z equal 30. So now this is equation 1, this is equation 3. Now from solving this, I am going to get equation b from here. Okay, let me write in the red color. So from equation, I am going to get b equation. Now, I need to solve for x. And to solve for x, I need to make the constant equally. So the constant in the second equation should be, or let's say, the coefficient in the third equation, because this is the third equation, this is the first equation. The constant, here is the 3. Here the constant is 1. So I need to make this value is equal to 3. So I have to multiply it with what? I have to multiply it by 3. But you can't just multiply the number. You have to multiply the whole equation by what? By 3. Okay? So now, if you multiply the whole equation by 3, so it will become 3x minus 3x times 3y times z times 17. So it's equal 3y minus 3z equal 21. Now let's write the third equation, negative 2y plus 7z equal 30. Now let's minus these two equations together. Okay, 3x minus 3x, they cancel each other. So negative 3y minus 2 become positive. So negative 3y plus 2y is equal negative y. Then negative 3z minus 7 is equal negative 10z equal 21 minus 30 is equal negative 9. Okay, now after we know the answer for each of these, now I have the second, will become the second equation. So this one will become equation b. So now I have equation a, I have equation b. So step number 4 said solve equation a with equation b to eliminate what? To eliminate y. Now I need to eliminate y. Now let's write equation a and equation b together. Okay, so now let's write them together here. So y minus 4z equal negative 5. This is equation what? This is equation a from here. Then equation b is negative y minus 10z equal negative 9. So now let's solve them together. Okay, let's add this to equation. Y plus negative y, they cancel each other. Negative 4z plus negative 10z is equal negative 14z equal negative 5 plus negative 9 is equal also negative 14. Now let's find z. So to find z, we need to divide both sides by negative 14. Divide by negative 14. So this cancel this. So z is equal negative 14 divide negative 14 is equal 1. So I found z. So do you remember the triangle that I told you? When I get z, I can replace it in this equation before to find what? To find y. Then I can replace it in the first equation to find what? To find x. So now I have z. Let's find now y, okay, by substituting z in one of the equation a and b, okay? Because we eliminate y by solving a plus b, right? So now you need to substitute z in a or b. You decide which one. So for example, let's take equation use the easiest equation. So I'm going to use equation a, okay? So y minus 4z negative equal negative 5. So now let's substitute z here. Y minus 4 times z, we found it, which is 1, equal to negative 5. So y is 4 times negative times 1 is equal 4, negative 4. So we plus 4 for both sides. So the answer is equal negative 1 for y. Now after we found y, I need to find x. And as I told you, to find x, we need to substitute in equation 1 or equation 2 or equation 3. You choose which one is easier for you. Now let's go back up, okay, to the first equation. Now I can see that the first equation, number 1, it's the easiest one because it's become like this, right? Because we divided by the common factor. So we can use this equation, which is same as equation 1, which is much easier for me. Okay, so now let's write it here down. Okay, find x minus y minus z is equal 7. So this is equation 1. Now x, okay, minus y is already negative 1, so we keep it negative 1. Then minus z already we found it, which is equal 1, equal 7. Now let's simplify. X negative become positive 1 minus 1 equals 7. So now we can negative 1 plus 1 cancel each other, so x is equal 7. So now I have x, I have y, I have z, so I can just write them x, y, and z. So the final answer will be x is equal 7, y is equal negative 1, z is equal 1. So this is the answer. This is how you can solve the equation. The book has the same way. If you look here, the book first step, he just divide the first equation by 5. So he got this one. Then the next step, he start to eliminate x. So he eliminated x by using this way. So x, so he become, this is equation A. So after he wrote equation A, he wrote it back here. Okay. Then step number 3, he solves equation 1 with equation 3. Okay. Then he got, this is equation B. Then he write it back here. Then in step 4, he solved equation B with equation. So this is equation A, this is equation B. He solved them together then until he got Z. So Z is equal this. Then after that, after he got Z, he substitutes Z here. Then after he got Y, he substitutes Y here and substitutes Z. Then he got the answer, which is this one. Okay, so this is what the book did in the same way that we are doing. Now, the second one, we call it here the augmented matrix. Augmented matrix is the matrix is the system that derived from the coefficient and the constant. So only coefficient and the constant that's in the equation. Okay, so system derived the coefficient and constant term, okay, of a linear equation. For example, look, so this is a system of equation. Okay, so from here to here, what do you think is happened? We just took only the numbers. Now we took 5, we took negative 5, we took negative 5, we took 35. So do you see all these? So the same thing now for the second one, which is negative. First we took only negative 1. Okay, then we take positive 2, negative 3, 12. So negative 1, 2, negative 3, negative 12. Same thing for the last one here, which is we took 3. Okay, we took negative 2, we took 7, 30. So 3, negative 2, 7, and 30. So this is what we call augmented matrix. So this one is the augmented matrix. Now, if I need to cancel these values, okay, and write the augmented matrix without them, this one it become coefficient matrix. Coefficient matrix without this value here. Okay, so augmented matrix with the value after the equal sign. Okay, the coefficient matrix is without the value. Okay, then we have something we call it row echelon form. So what is exactly row echelon form? Row echelon form, when you are trying to solve the augmented matrix and make the inverted triangle. Okay, inverted triangle that we learned, which is we can make this one 1, this is 1, and this is 1. Okay, so augmented row echelon form can be in different form or different based on the matrix. For example, so let's say I have 1 0 0, and I have 0 1 0, and I have 0 0 1. Okay, then I have any number here, whatever the numbers. So this is first form, and I have another form for echelon form for row echelon form, 1 0 0 1, and whatever the number become here. So as you can see, my goal is always to make it as a row echelon form. So this is the row echelon form. Do you see it? When I have 1 here and 1 here, 1 here, so all the values here and here are equal to 0. Now let's learn how to write the augmented matrix for everyone. First step, sometimes the question comes tricky. So why? Because they are not giving you all the variables. Some variables are equal to 0, so they don't include it to the equation. So for example, look, first step that you need to do is to count how many variables in the example. How many variables? Here I have w, I have x, I have z. Then x is repeated, I have y. Then z repeated, w repeated, this is repeated. So all of these are repeated. So now how many variables do I have in all equation? W, x, y, z. So first step, write them w, x, y, z. Okay, so this your matrix will become or will have 4 different variables. Now any variable that missing from the equation, we substitute it with 0. So any variable not given, we substitute with 0. So first thing, w, what's the value? W is 1. Okay, then x is equal 4. Do I have y? Y is 0. Do I have z? Z is 1. Okay, don't forget. Then after that we have here 2. So this is the first equation. Now the second equation. Do I have w? No, 0. Do I have x? Yes, 1. Do I have y? 2. Do I have z? Yes, negative 3. Then 0. Now in the third equation, do I have w? Yes, it's 1. Do I have x? No, x is 0. Do I have y? Yes, it's negative 3. Do I have z? Yes, it's negative 8. Then negative 1. The last row is 3. Then I have x2. Then I have 3y. Then I have 0z. Then I have 9. So this is my augmented matrix. Okay. Now try to solve this one by yourself and tell me what you are going to get. Now same thing here. Try to solve this question. Let me just show you how to, or let me show you the answer. So after you finish, you can get the answer. Oh, this is some question that you need to solve them using Gaussian elimination. Don't forget, first thing you need to write solve equation triangle using Gaussian elimination. Gaussian elimination the same way that we did before. Then, now the Gauss-Jordan elimination. The second objective, which is Gauss-Jordan elimination, we have here 3 different way, okay, or let's say we have 3 different solution when we start trying solve the matrix or the linear system of equation. For example, here, the first thing that we need to understand that we need to make this matrix as row echelon form. So as you can see, reduced row echelon form. Row echelon form when you have 3 ones, okay, diagonally. Which is you need to make this value equal 1, you need to make this value equal 1, you need to make this value equal 1. Then after that, you need to make this one here, and this one here, and this one here equal to 0. So if you are able to make this 3 diagonally, okay, equal to 1, okay, and these values equal to 0, so that means this matrix has one solution. Now, if you are trying to make the diagonally equal 1, but at the end you can't make this value equal 1, okay, so that means this matrix has no solution. Okay, then after this, for the infinite solution, now when you're trying to make this one 0, 1 and 1 diagonally 1, and you can't make this value equal 1, and this value here is still equal 0, so when you have this value is 0, this value is 0, so this is considered as infinite solution. The difference between infinite and no solution, this value is 0, and this could be any number. So when you have 0, which is equal to a number, so this is no solution. But when you have 0 equal to 0, so this is infinite solution. Another way to find or to know the infinite solution, when you're trying to make diagonally equal 1, but at the end you can't make the last row equal to 1. So look to this 2 value. Okay, you can't make this value equal to 1 and this one become, let's say, 0 or whatever. So that's mean also this one considered as infinite solution. Okay, so this is just a random, or let's say this is just an explanation how to identify between no solution, infinite solution, and one solution. Okay, so one solution, all of them diagrams equal 1. No solution, this can be 1, but this one is 0 equal to any number, so there's no solution. In the infinite solution, we have to wait if there's two zeros and this only two ones, so infinite solution, or you can't make the last row to find the last variable. So this is how we can know the three type of matrix. Now let's take example about each of them to understand how we can solve the system of equation. Now, solving system of equation use Gauss-Jordan elimination. So Gauss-Jordan elimination, which is the matrix. Now let's start. The first step to solve any question is to write the augmented matrix. So the augmented matrix that we need to write. So let's write it. So x. So this is the row is x. This row is y. This row is z. Then we have the end, which is the number after the equal. So 1, -1, 1. Here -1. 2, -3. Okay, then here we have 2, -3, 5. Then here is 0, here is -5, here is 8. Now after we write the augmented matrix, the second step is to make this value equal 0. This value in which row? This value is in row 2. Okay, so now to solve this value, I need to solve it with row 1 with row 2. Okay, so now let me just make it easier to you. Just really quick example. Okay, so you will be able to solve any matrix. So first thing, let's write the row echelon form 1 0 0 0 1 0 then 0 0 1. Okay, so this is row echelon form. Now it's already also 4 steps. Step number 1, make this value equal 1. Okay, how to make this value equal 1? You need to multiply row 1 by any number, or you divide row 1 by any number. Okay, now second step is to make this value here in row 2 equal 0. How to make this value equal 0? How to make it equal 0? So you need to work, okay, solve row 1 with row 2. Okay, now you need to make this value equal 0. So if you need to make this value equal 0, number 2, solve row 1 with row 3. Now we need to make this value equal 0. So step number 3, solve row 2 with row 3. Okay, that's it. This is what you have to do. Now let's start solve the rows together. So let's solve row. I need to make, so as you said, I need to make this value equal 0. Let me write it in red color. So I need to make this value equal 0. So to make this value equal 0, okay, I need to solve row 1 with row 2. Now, when you start solving, before you start solving, first step, ask yourself this question. I am trying to make this value, okay, equal 0. Okay, and this value in which row? This value in row 2. Perfect. So if I need to solve a row and make a value in that row equal 0, what will happen with the other rows? For example, this one is row 1, this is row 2, okay, this is row 3, right? Now the value that I need to make 0, it's in row 2. What happened with now with row 1, row 3? They are going to stay same. Okay, so anytime you need to work on the value, the other rows stay same. Don't change anything in the other row. So row 1, okay, row 1 stay 1, -1, 1 and 0. Okay, row 3, 2, -3, 5 and 8. Now let's work on row 2. So before you start working on row 2, I need to know the values. To know the values, I need to create or to write a rule. What is exactly the rule? First, write R1 and R2. Now, to make this value equal 0, okay, first step, you need to make this number and this number equal. If you make them equal, then you can just minus them or add them, then they become 0. So as you can see, this x here is 1, and also here x is equal 1. So I don't have to multiply any number. So I can just add or minus them. Let's add or minus them. So 1 plus, okay, let's create the rule, 1 plus row 2. So row 1, 1 plus row 2, this row 2, negative 1. So the answer is 0. Then again, let's continue. We finish from the second. Now let's go start with the with the first term. Now start with the second. So negative 1 plus row 2, this is row 2, which is equal to, so the answer is equal 1. So cancel, done. Now let's go to row 1. Row 1 is 1. Okay, then plus row 2, negative 3. So negative 3. So 1 plus negative 3, negative 2. Finish. Now let's go next. Row 1 is 0 plus row 2, okay, is negative 5. So negative 5. So the answer is negative 5. Done. We finish. So now we made, so did we make this value equal 0? We finished from step 1. Step 1 is done. Now step 2, solve row 1 with row 3 to make this value equal 0. Now let's go back here down. So I need to make this value equal to 0. So to make this value equal to 0, I need to solve row 1 with row 3. Now let's write the new matrix. Now as I told you, if I need now to solve any two rows, what happened with the other rows? So this is row 1, this is row 2, okay, this is row 3, right? I need to make the value in row 3 equal 1. What will happen with row 1, row 2? They are going to stay same, no change. Negative 1, 1, 0. Then 0, 1, negative 2, negative 5. Now, row 3, I need to create the rule. So, row 1 with row 3. Okay, now look to the row 1 and row 3. First, as I told you, I need to make this value here equal to this value here. So, this value here below, it's 2. This value here is equal 1. Now, they are not equal. So, I have to multiply. Always, when the two values are not equal, I have to multiply one of the values by a number to make it equal to the other values. For example, this is number 2. This is number 1. So, I can multiply 1 by 2. So, 2 times 1, the value will become 2. So now they are equal. But when you're multiplying, you are not multiplying only one value. You must multiply the whole row. So all of this row should be multiplied by what? Should be multiplied by 2. Okay? So now let's multiply the whole row by 2. Okay? Now, let's multiply the whole row by 2. Okay? Sorry. So row 1, all the whole row 1 will be multiplied by 2. So after I multiply this one by 2, so this value become 2. So this value is 2, okay, and this value is 2. And to make this value here equal 0, I need to minus this value, which is after it becomes 2, minus 2. So the answer is equal 0. So now the rule is 2r1 minus r3. Okay, so now 2 times row 1. What is row 1? 1 minus row 3, 2. So the answer is equal 0. Done. Finish. Now let's continue. 2 times row 1 is negative 1 minus, okay, sorry, what's this? This should be 2. Okay, then minus row 3. Row 3 is equal negative 3. So negative 3. Okay, so now 2 times negative 1, negative 2, negative positive 3. So the answer is equal 1. Okay, so we finish from this. Now let's continue. 2 times row 1 is equal 1 minus row 3 is equal 5. So 2 minus 5, negative 3. Okay, so we finish from this. Now the last one, 2 times 0 minus row 3 equal 8. So the answer is equal negative 8. We finish? Yes, now we finish. So this is the new matrix after we multiply them. Now the next step, let's go up. number 3. We finish from step number 2. Now step number 3, solve row 2 with row 3 to make this value equal 0. So row 2 with row 3. Now I need to make this value equal 0. So this value in which row? It's in row 3. We know that's row 3. This is row 2. This is row 1. So what will happen with the other rows when I when I make this one 0? They are going to stay same. So row 1 stay same. Row 2 stay same. Okay, now I need to find what is row 3 will be. Now because this value is already 0, it stays 0. But let's create the rule. Now let's say my goal is to make this value equal 0. And this value is already 1. So this value is 1, this value is 1, so they have same number. So can we just simply minus them? So we say row 2 with row 3. Now row 2 is equal 1 and row 3 is equal also 1, so we can just minus them to get the 0. Okay, so first, now 0 minus 0 is still 0. Done. Now then 1 minus 1 also 0. Done. Then negative 2 in row 2 minus row 3 negative 3. So negative 2 plus 3 equal 1. Okay, finish. Then the last one, negative 5 minus negative 8. So negative 5 plus 8, which is equal 3. Okay, so now we finish. So as you can see here, we finished from all the 3 rows. Okay, as you can see. So we made it diagonally. Now the step is so easy. Okay, is to make, we understand from the first step, we said that, okay, this is row echelon form. Now this row is x, this row, this column, sorry, is x, this column is y, this column is z, and this is the number after the equal sign. Okay, so what you have to do first is to find, okay, 0, okay, use row 3 to find z, use row 3 to find z, use row 2 to find y, use row 1 to find x. So this is give you x, this is give you y, this is give you z. So now let's write 0x plus 0y plus 1z equal to 3. So this is 0 already, this is 0 already. So 1z means already z. Z is equal 3. We are done from z. Now after I found z, I need to work on row 2 to find y. So now let's write row 2. 0x plus 1y plus negative 2z. Okay? Then equal negative 5. Now we have z, so let's substitute z. Okay, so this is 0. 1y means y. Negative 2, negative 2 times z, which is equal to 3, equal negative 5. So y is negative 6 minus negative 5. So y plus 6 for both sides is equal 1. So we're done from y. Next, now I need to find what? I need to find x. Okay, so to find x, I need to make, okay, let's find it here. I need to use row 1. So row 1 is 1x, okay, plus negative 1y plus 1z equals 0. So 1x is already x. Negative 1 times y is 1, plus 1 times z is equal to 3, plus 0. Now x minus 1 times 1, 1, plus 1 times 3, 3, equals 0. So now x, negative 1 plus 3 is equal, plus 2 equals 0. So we take minus 2 to the other side. So x is equal 2. Now the answer, okay, will be xyz, xyz. So x is equal 3, sorry, x is equal negative 2, y is equal 1, z is equal 3. Done. Okay, so this is the answer from the same thing. Okay, if you would like to make the other rows equal 0, okay, similar to the book. So the book, we stopped here until this step. Okay, now if you need to make row echelon form, okay, which is, we already made these 3 value equal 0. we finish. If you need now to make this 3 values equal 0, you can continue solving rows together. For example, I need to make now, okay, I need to make this value equal 0. So I have to solve row 2 with row 1. Now if I need to make this value equal 0, so I have to solve row 3 with row 1. Now if I need to make this value equal 0, so I need to solve row 3 with row 2. Okay, so just solve them by normally that as we did, then you find the answer. So the final matrix will be in the shape of row echelon form. We're done. Okay, I hope you understand. Now it's your turn. Try to solve this equation. Okay, and always start by using the same way that I told you here. Solve row 1 with row 2, solve row 1 with row 3, solve row 2 with row 3. Okay, so first solve all of them. In step number 4, okay, divide, okay, divide row 1 or row 2 or row 3, okay, to make, okay, row echelon form. What I mean, for example, if you start solving the row echelon form and you get here, for example, 3, 0, 0, and you get here, for example, 2, 0, and you get here, for example, 5, okay, and any number here and here, okay, and numbers here and here. So we, as I told you before, this one should equal, should be equal 1. So what you have to do, you can row 1 divide by 3. Row 2 can be divided by 2. Then row 3 can be divided by 5. So first start following the steps. Okay, step 1, step 2, step 3, then step 4, divide every column by the number. So after you divide the row echelon form, it will become it will become 1 1 1 0 0 0. Okay, so this is what you are going to do. Okay, now try to solve this, and if you have a question, please let me know.